The first thing we need to be able to do is to draw a picture, or at least a rough sketch of what's going on. Each of these should be fairly straightforward for us to sketch. We just kind of need to make sure we get them on the graph more or less accurately. The fact that I only care about the first quadrant means I'm only going to worry about that first quadrant. Y equals 1 over x in the first quadrant is doing something like that. And I know that y equals x squared is doing something like that. And then y equals 9 is going to be a flat line. And the only thing I really have to know is the flat line down here or is the flat line up here? So the only way that I know to do that is to think about what's that intersection point. Finding that intersection point, I'm looking at x squared is equal to 1 over x, or if I multiply that x over, x cubed is equal to 1. So that's an x value of 1, and 1 squared means it's also a y value of 1. Now I know where to put my y equals 9 line. Well, there's only one region on this graph that's bounded by all 3 curves, and that's this chunk in here. So the next thing that I need to figure out is whether I want vertical or horizontal cross sections. We can find the area either way. If I look in this region, I know that if I'm standing right here and I look up, I see the y equals 9 line, and if I look down, I see the 1 over x. And if I scoot over a little bit so that I'm over here, well, when I look up, I see the y equals 9 line, and when I look down, I see y equals x squared. So if we do vertical cross sections, we'll have to write this as 2 separate integrals. Alternately, we could switch to doing horizontal cross sections, because anywhere that I am in the region, my right-hand wall is x squared, and my left-hand wall is 1 over x. Does anyone have an opinion of whether we should do vertical or horizontal cross sections? You can type a V or type an H. I see a couple H's, so why not practice with those horizontal cross sections? Now that I know we're going to put a horizontal cross section in there, I'm going to start by getting as much partial credit as I can. Well, I know the area is equal to base times height. I know that my height of my rectangle is a little bit of dy. I know that this is going to be a right minus a left function. And I can even do my limits of integration because I can already see that these are going to come down as far as y equals 1 and up as far as y equals 9. Now all we have to do is to plug in our left and right functions. When we're doing horizontal cross sections and we're going to be integrating with respect to y, that means that our left and right functions have to be rewritten so that they say x equals. If y equals 1 over x, that means that x equals 1 over y. And up here, if y equals x squared, then taking the square root of both sides, that means x equals the square root of y. Plugging those in for our right and left functions, on the right-hand side, I'm going to have that square root of y. And on the left-hand side, I will have 1 over y. And that's all we would need to do to set up finding the area. And now it looks like, sure, let's do, if we had chosen vertical cross sections, It won't take me a minute to do that, so let's go ahead and get vertical cross sections. To do vertical cross sections, I already know that we're going to have to break this into two pieces. And although we found this intersection point between these two curves, in order to do vertical cross sections, I also need to know what these two bounds are. This one over here is the intersection of y equals 9 and y equals x squared. We can probably do that in our head. So if I set 9 equal to x squared, this must be 3. And this line over here is the intersection of y equals 1 over x and y equals 9. So if 9 is equal to 1 over x, then x must be equal to 1 over 9. And this point would be 1/9. That means that in terms of our integrals, I'd be going from 1/9 to 1. And in that region, my top function is 9, and our bottom function was 1 over x. And then for the second part of the curve, we would be going from 1 to 3. And now our top function is still y equals 9, but our bottom function was x squared. If you finished both of these integrals off, you should get equivalent answers. If I had to actually do one of these problems, honestly, I'd probably do this one because I wouldn't have to think as hard on the integrals, but that's just me. So there's a question about how I got this 3. So I didn't write that out, I said it out loud. Let me actually write that. This 3 is coming from the intersection of our y equals x squared line and our y, or it's not a line, it's a curve, from our y equals x squared and our y equals 9. So if I set those equal to each other and 9 is equal to x squared, technically we'd get the plus or minus 3, but that -3 wouldn't be in our first quadrant. So x would just be 3. That's where my 3 came from there. Other questions before we do another area problem or maybe another improper integral? Okay, I'm not seeing any more questions popping up in the chat. Area or improper integral? What do you want to do next? Oh, just to quickly address the answer in the chat, should that be the answer? Based on what Dedell has told us, we quit here because the question is going to say set up. The way that I've worded this to say find the area, you would want to actually evaluate it. My understanding from both having watched Dedell teach for the last 15 years and what he said in class, I really believe that if the question is showing up on a quiz or the midterm, it's going to say set up and integral to find the area. Yeah. So you wouldn't have to finish these. So we should be able to. So an improper integral or another area practice. Anyone have a vote? You can type it into the chat if you do. Okay. So let's do another, this time I'll leave my instructions up, set up an integral for the area. And this time, let's do the area between x equals y squared and x equals y plus 6. If this is the area that we're being asked to find, we're actually being given a clue already that we ought to use horizontal cross sections. Both of our functions are already written as functions of y, which means doing horizontal cross sections allows us to have that dy component. We could do this with a picture or without a picture. I'm going to give it a shot without a picture and see how we do. I know that we're going to need to find the intersection points because this time we weren't given any guidance about like it being in the first quadrant or something. So we need to find those intersection points. If y squared is equal to y plus 6, hopefully I have given us something that factors. That was my intent. So I am looking at y plus 2 times y minus 3, which means these are going to intersect at y equals -2 and at y equals 3. I already know now that I can start setting up my integral. I'll be going from -2 to 3 dy. Now in terms of our right minus left, what that's going to mean here is we need to know which of these functions has the larger x value when we choose a number between -2 and 3. I'm going to choose 0 because it is between -2 and 3. So if I choose y equals 0, then this function, I'd have x equals 0 squared. Or for this function, I'll have x equals 0 plus 6. This is my larger value, which means it should be to the right of the other function. And I'm going to end up with y plus 6 minus y squared.